Hello guys, how are you all doing? I hope you're all set for Class 10 Mathematics Chapter 5, Arithmetic Progressions Exercise 5.1. Let's begin. Question number 1 says, in which of the following situations does the list of numbers involved make an arithmetic progression and why? In this question, we have 4 sub-questions. Let's solve the first one. The taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for the each additional kilometer. Now what does this mean? That means first the taxi fare after each kilometer when the fare is rupees 15. Now the fare is rupees 15. For the first kilometer only. So, rupees 15 is for the first kilometer. Then we have the next part of the question which says, and rupees 8 for each additional kilometer. That means, rupees 15 is our initial for first kilometer. And if you travel 2 kilometers, then it means additional rupees 8. This is your second kilometer. That means first kilometer plus rupees 8 will add you to the additional kilometer and will give you the final price of 2 kilometers. And this turns out to be rupees 23. Isn't it? Rupees 23 is first kilometer plus second kilometer. Alright. First kilometer is rupees 15 which is already known. But second kilometer, the additional 8 rupees are being added, isn't it? So the final cost for both the kilometers is rupees 23. Now, when we move ahead, my initial cost is rupees 15. Now, if I travel 3 kilometers additional, then it's going to be rupees 15 plus rupees 8 plus rupees 8. And what is this? This is third kilometer. That is second kilometer plus rupees 8 will give you the third kilometer cost, which turns out to be, we know the second kilometer cost, which is rupees 23. Now 23 plus 8 turns out to be rupees 31, which is your second kilometer plus rupees 8. Now, what are we able to understand from the question? For first kilometer, it is rupees 15. But moving on, if I travel 2 kilometers, then it will be rupees 15 plus 8. For each additional kilometer, you have to pay rupees 8. But for the first kilometer, it is rupees 15. Now, I have to write this in the form of an AP and just check whether the list of numbers involved are in the form of AP or not. Now, the first one I already know it is 15, isn't it? The first kilometer is 15. So, 15 comma, then first kilometer plus second kilometer gives me rupees 23. So, 15 comma 23 comma, then second kilometer plus rupees 8 gave me 31, isn't it? So it is 15 comma 23 comma 31 comma, let's find another one, right? Now I'm going to take the fourth kilometer into consideration right now. So it's going to be third kilometer plus rupees 8, isn't it? Now what was our third kilometer? It is 31 rupees, isn't it? So the fourth kilometer will be equal to 31 plus rupees 8, which turns out to be what? Rupees 39, isn't it? 31 plus 8, which turns out to be rupees 39. So the next set of number is 39 and so on. Now I have received my set of numbers and I'm going to check whether this set of numbers is in AP or not. So how do I do that? Basically, if you have to check whether the given set of numbers is AP or not, then you have to check their common difference. Now, what is this common difference? Now, 31 is your third term and 39 is your fourth term. First, let's label the terms. The terms in AP are labeled as, let's suppose, say 15. 15 is your first term, so it is represented by A1. 23 is your second term, represented by A2. Then we have 31, which is your third term, represented by A3. And then we have 39, represented by A4. Now, how do we find the common difference? Once you find the common difference, and you see that the difference between any two numbers turns out to be same, then the given set is an AP. So how do we find out the common difference? Now here I have A4 and A3. Among the set of numbers, if I have to find out the common difference, it will be A4 minus A3. Now the common difference will be what? 39 minus 31, which turns out to be 8. Isn't it? Now between these two we have 8. And then we have 31 and 23. Now the common difference turns out to be what? Common difference is equals to A3 minus A2, isn't it? So the common difference will be A3 minus A2. And remember, it's never going to be A1 minus A2 or it's never going to be A2 minus A3. Always the next term will be subtracted, okay, from the succeeded term. Alright, that means here I have A4 and A3, right? Let's suppose say this is A3 and A4. Then I'm going to subtract A3 from A4. It's going to be A4 minus A3 and that's what we performed here. Then we have A3 minus A2. What is A3? A3 is 31 and what is A2? It is 23. The common difference turns out to be 8 again, isn't it? And then when I try to find the common difference of A2 and A1, that means A2 minus A1 will give me 23 minus 15, which yet again turns out to be 8. Right, 8, 8 and 8. So the common difference in the sequence of numbers turns out to be 8. And if the common difference is same across all the numbers, then the given list of numbers involves or makes an arithmetic progression or AP. Therefore, this set of numbers, that is 15, 23, 31 and 39 together form an AP. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Now here I have a cylinder which is containing some volume of air. And I am assuming that the volume of air present in the cylinder is V. Okay, then going to the next part of the question. On the other hand, I have vacuum pump which removes 1/4 of the air. 1/4 of the air means 1/4 into V because the volume of air has been assumed as V. So 1/4 of the air is removed from that particular cylinder at a time. Okay, so now I have V as my initial amount of air present in the cylinder, and from that 1/4 of the V is removed. Okay, so this turns out to be what? This turns out to be 4V minus V upon 4 on taking LCM. Then we get 3V upon 4 as our next set of number. First set of number is V. The next set is 3V by 4. Now moving ahead. Now the remaining volume is 3V upon 4. Now in this 3V upon 4 again 1/4 of the air is removed, right? So it's gonna be 3V upon 4 into 1/4. Then on simplifying this, we get 12V minus 3V by 16 on taking LCM, which in turn gives us 9v upon 16. Now, our set of numbers are v, 3v upon 4, 9v upon 16. Now, in this particular set of numbers, do you find any common difference? I don't think so. Let's try it out. 9v upon 16 minus 3v upon 4 gives me what? I'm going to take 16 as the LCM, so it's going to be 9v minus 12v, which is minus 3v upon 16. This is my common difference in the case of A3 minus A2. Now what about the next one? I have 3v by 4 minus v, which on simplifying, we get 4 as LCM and 3v minus 4v, which in turn gives me minus v upon 4. And if you observe, are the common differences same? No. When the common differences are not same, the given set of numbers are not in AP. Moving forward, we have the cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. Now, the cost of digging a well for every meter after digging, that means 1 meter, it costs rupees 150, and followed by the second meter will be what? Second meter, rupees 150 plus rupees 50. Okay, and it rises rupees 50 for each subsequent meter. That means first meter, its cost is rupees 150. But when we move on to the next subsequent meter, it turns out to be rupees 150 plus rupees 50. Now moving on, we have third meter, which turns out to be rupees 150, which is common, plus rupees 50 plus rupees 50. Now this is the cost of the second meter. The third meter will be plus rupees 50 again. Plus rupees 50 plus rupees 50 and so on. Now this turns out to be, the initial one is 150. Then we have 200. Then we have 250. Now let's write it. 150, 200, 250. Now is this an AP? Well, it is an AP because its common difference is 50 all the time. Right? When its common difference is same across all the numbers, the given set is an AP or an arithmetic progression. The amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. Here the thing you have to understand is about compound interest. Compound interest is basically interest over interest. Now in this case, let me make it more clear. Here I have the amount of money with me as, amount of money is rupees 10,000. Now after 1 year, after depositing a compound interest of 8%, how much money would I have? Well, that's going to be, after 1 year, it's going to be 10,000, that is your initial amount, multiplied with 8 upon 100. Why? Because here 8% per annum is being deposited. So here this and this two zeros get cancelled. You'll be left out with 800. But wait, we're not yet done. This is the interest you're adding to your account. But the initial amount you have is rupees 10,000. That means after 1 year, your amount will be 10,000 plus 800. Because an interest, a compound interest of 800 is being added every year. So here it's going to be 10,800 now. So after 1 year, what is your amount of money left in your bank account? It is 10,080. Now try to form the sequence. Okay, then after 2 years, now let's talk about after 2 years so that we can understand it more precisely. So after 2 years, it will be 10,800, that the initial amount you have, multiplied with 8 upon 100. Why 8 upon 100? That's because here we have 8%, isn't it? Now these two zeros get cancelled. You'll be left out with 108 into 8, which is 864. Now, is this the money you have right now? No. You're going to add 10,800 to 864, right? So after 2 years, your money will be 10,800 plus 864, which turns out to be 11,664. Now, try to form the sequence right now. Here, this is your first one. Rupees 10,000 is your first number, followed by 10,800 and then followed by 11,664. But here, if you observe, the sequence is going to be 10,000, 10,800, 11,664, and so on. Right? This is the sequence. But is this sequence an AP? Do you think it's an AP? Here the difference we have is 800. And here the difference we have is 864. The common difference is not same. When the common difference is not same, then the given sequence does not make an AP. Right? So, the statement given here does not make an arithmetic progression. Moving forward, we have to write the first 4 terms of the AP when the first term A and the common difference D are as follows. The first term is 10 and the difference is 10 again. Now I have A1, A2, A3 and A4 as my first 4 terms. And I know the common difference D. Okay. Now, we have to find the value of A2 first. So, can I write A2 minus A1 is equal to 10 because my common difference is equal to 10. Here A2 is the second term, A3 is the third term and A4 is the fourth term and so on. So here A2 minus A1 will give me the common difference as 10. Now A2 is the unknown value. A1 is already known to us, which is 10. And this must be equal to 10. Now A2 will be equal to 20. So the value of the second term is 20. Now moving forward, A3 minus A2 is equal to 10 because my common difference is 10. A3 is unknown but A2 is known to us, which is 20. Now A3 value turns out to be 30. Okay. Now moving forward, we have A4 minus A3 is equal to 10. What is the value of A4? That is unknown to us. But A3 is 30 equal to 10 and A4 is equal to 10 plus 30, which is equal to 40. Now what is my series? The series is 10, 20, 30, 40. These are my first 4 terms in the series of AP, where I was known with the first term A and the common difference D, and I was able to acquire the next 3 terms. Moving ahead, I have A as minus 2 and D equals to 0. Now, A is equal to minus 2, A1 is equal to minus 2, and the series goes like this, A2, A3, A4, and so on. But here we are asked to write only the first 4 terms. Now, A2 minus A1 gives me 0. The value of A2 is unknown, so A2 minus of minus 2 gives me 0. A2 plus 2 is equal to 0 and A2 is equal to minus 2. The value of A2 is minus 2. And then A3 minus A2 is equal to 0. What is the value of A3? Is unknown to us, but A2 is equal to minus 2, which is equated to 0. Now A3 plus 2 is equal to 0 and A3 turns out to be minus 2 yet again. Now, A4 minus A3 is equal to 0. The value of A3 is minus 2 equated to 0. A4 plus 2 is equal to 0 and A4 turns out to be minus 2. Now what is my series? The series is like this. Minus 2, comma, minus 2, comma, minus 2 and minus 2. Because here my common difference is 0. So the terms are equal. Moving forward, A is equal to 4 and D is equal to minus 3. So A1 is equal to 4 followed by A2, A3, A4 and so on. Now, A2 minus A1 is equal to minus 3 because the common difference is equal to minus 3. The value of A2 is unknown, whereas the value of A1 is known to us. Minus 4 is equal to minus 3. A2 is equal to minus 3 plus 4 and A2 turns out to be 1. Moving forward, we have A3 minus A2 is equal to minus 3. The value of A3 is unknown, whereas A2 is known to us, equal to minus 3. A3 is equal to minus 3 plus 1 and A3 is equal to minus 2. This is the second value which we have acquired, but this is the third term. Then A4 minus A3 is equal to minus 3. A4 minus 2 is equal to minus 3. Now A4 plus 2 is equal to minus 3. A4 is equal to minus 3 minus 2. A4 is equal to minus 5. Now what is our series? The series is 4, 1, minus 2, minus 5. This is our AP series of 4 terms. Moving forward, we have A as minus 1 and D as 1 by 2. Well, now A1 is equal to minus 1 followed by A2, A3, A4 and so on. Now, A2 minus A1 is equal to 1 by 2 because my common difference turns out to be 1 by 2. Now, A2 minus of minus 1 is equal to 1 by 2. A2 is equal to 1 by 2 minus 1 and A2 turns out to be 1 minus 2 upon 2 and this in turn is A2 is equal to minus 1 upon 2. So the value of A2 is minus 1 upon 2. Now moving forward, A3 minus A2 is equal to 1 by 2. What is the value of A3 is unknown to us, but A2 is minus 1 by 2. Now A3 plus 1 by 2 equals to 1 by 2 and A3 turns out to be 0, isn't it? The value of A3 is 0. Now moving forward, we are going to find out A4. So A4 minus A3 is equal to 1 by 2. 0 minus, well wait, we don't know what is A4, isn't it? So it is A4 minus 0 is equal to 1 by 2. And the value of A4 turns out to be 1 by 2 plus 0, which is 1 by 2 itself. Now what is our series? Our series is minus 1, minus 1 by 2, 0, 1 by 2. This is our AP series. Now the method we followed was very complex. Let's start a different method for this particular question. A is equal to minus 1.25 and D is equal to minus 0.25. Now the sequence of AP is like this. A, A plus D, A plus 2D, comma a plus 3d, and you know that, right? A plus 4d, a plus 5d, a plus 6d, and so on. This is the sequence of AP. The method we followed in the previous cases was a kind of complex, isn't it? We had to find out every term using the common difference. But have a look at this particular sequence. This seems to be more easy than the previous ones. Let's try it out. First, in our sequence, we have minus 1.25. That is A. Then, the second term is A plus D. That means A2 is equal to minus 1.25 plus minus 0.25. Now this kind of is way far more better than the previous methods we have used, right? So A2 is equal to minus 1.25 minus 0.25. Now what is the value of A2? It is A2 is equal to minus 1.50, isn't it? The value of A2 is minus 1.50. Now we found out the second term. Now let's try to find out the third term as well using the same procedure. So this is your first term, this is your second term. Now we're going to find out the third term, A plus 2D. Understood? Now if it is third term, you're finding out 2D. Right? You're multiplying 2 with D. But in the fourth term, you'll multiply 3 with D. That means if you're going to find out 99th term, it's going to be A plus 98D. As simple as that. You're just going to kind of subtract 1 from whatever the number you want, right? From whatever the term you would like to have. Now here, I want my third term. So third term will be A plus 2D. As simple as that, isn't it? Basically, the formula is AN is equal to A plus N minus 1 into D. We are just applying this formula and trying to find out. Okay. Now, we're going to find out the third term, right? So what is the value of A? Minus 1.25 plus 2 into 0.25. That's going to give you next term. Precisely speaking about the third term over here. Now, this in turn will give you minus 1.25 plus what is 2 times 0.25? It is 0.5 or 0.50, isn't it? This in turn will give you, well, this was minus, isn't it? So it's going to be minus 1.25 minus 0.50. Getting my point? Because the common difference was minus 0.25. So here we're going to substitute minus 0.25. Right. So this in turn will give you minus 1.75. Now what is this? This is your A3. Alright, now we're going to find out the last term which we require. For the last term, we're going to use A plus 3D. Well, this will give you minus 1.25 plus 3 into 0.25. Isn't it? So A plus 3D is minus 1.25 plus 3 times minus 0.25. Now this is going to be minus 1.25 minus 0.75. Alright, so this in turn will give you minus 2.0 or basically minus 2. Alright, so what was our sequence? Did you forget the sequence? The sequence was minus 1.25 comma minus 1.50 comma minus 1.75 and at last we had minus 2.0 and so on. And this forms our arithmetic progression. Moving on to the third question. For the following APs, write the first term and the common difference. So in this AP, what is the first term or the first number of the sequence? That is your first term, isn't it? The first number of your sequence is 3. So the first term is 3. As simple as that, isn't it? Then we have common difference. How do we find out D? D is equal to A2 minus A1, isn't it? The second term minus the first term will give you the difference or the common difference. This in turn will give you 1 minus 3, which is going to give you minus 2. So what is the common difference? The common difference is minus 2. And what is the first term? The first term is 3. Moving ahead, we have minus 5, comma, minus 1, comma, 3, comma, 7. So what is the first term of the series over here? The first term is minus 5, isn't it? So what is the value of A1? A1 is equal to minus 5. Now you're going to find out the common difference. D is equal to A2 minus A1. That is the second term minus the first term will give you what? Will give you the common difference. Now what is A2? A2 is minus 1 minus of what is A1? It is minus 5. So minus 5. This in turn will give you minus 1 plus 5, which will give you 4. So what is the common difference in this case? The common difference or the D, the value of D is 4. And what is the first term? The first term is minus 5. 1 by 3, 5 by 3, 9 by 3, 13 by 3 and so on. In this, what is the first term? The first term is 1 by 3. So what is the value of A1? A1 is equal to 1 upon 3. Then, how do we find out the common difference? The common difference is A2 minus A1. Now, what is the value of A2? The value of A2 is 5 by 3, isn't it? So, 5 by 3 minus, what is the value of A1? It is 1 by 3. So, 5 by 3 minus 1 by 3 will give you the common difference, which is 4 upon 3. So, what is the common difference? It is 4 upon 3. And the value of the first term is 1 upon 3. Moving ahead. Again, the same kind of question. We have the fourth sub-question on our screen. 0.6, 1.7, 2.8, 3.9 and so on. So here, what is the first term? The first term or A1 is equal to 0.6. Now, what is the common difference? D is equal to A2 minus A1. What is the value of A2? The value of A2 is 1.7 minus what is the value of A1? It is 0.6. Now, what is 1.7 minus 0.6? Well, it is 1.1, isn't it? So, what is the common difference in this case? The common difference is 1.1, whereas the first term is 0.6. Now, moving on to the fourth question. Which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. So, here we have the first sub-question which says 2, 4, 8, 16. Now, for any sequence to be AP, right? So, what is the sequence over here? 2, 4, 8 and 16. For any sequence to be AP, their common difference must be same or the common difference must be equal. Right. So, first 4 minus 2 or A2 minus A1. What is it? 4 minus 2, which is 2. So, the common difference is 2. Then we have A3 minus A2, isn't it? Which is 8 minus 4, which is 4. So, here the common difference is 4. And here if you observe 16 minus 8 will give you 8. Isn't it? A4 minus A3 will give you 8. Now in any of the cases, do you find the common difference same? No, 2 is not equal to 4, not equal to 8. So here the common differences are not same. So the given sequence, that is 2, 4, 8, 16 does not form an AP. It is not an AP. Alright. Moving ahead, we have 2, 5 by 2, 3 and 7 by 2. Now, in order to find out the common difference, let's make all the denominators equal. In fact, we're going to take out the LCM. Alright. So what do we get? This can be written as 4 upon 2. This is 5 upon 2 as usual. And this is going to be 6 upon 2. And this is 7 upon 2. Now, in order to find out whether this sequence is AP, what are we going to find out first? We're going to find out the common difference, isn't it? So A2 minus A1. What is A2 minus A1? 5 upon 2 minus 4 upon 2, which is 1 upon 2. Very well. Then we have A3 minus A2, which is 6 upon 2 minus 5 upon 2. Well, we have 1 upon 2 again, isn't it? So here we have the difference as 1 upon 2. Here too we have the difference as 1 upon 2. Let's see A4 minus A3. Right? So it is 7 upon 2 minus 6 upon 2, which is 1 upon 2 again. Well, so the common difference in every sequence is same, isn't it? So this sequence is an AP. And when we move on to the next part of the question, they're asking us to find out the common difference D. And we know that the common difference D is 1 upon 2. Right? And we're going to write the next 3 terms. Okay, apart from 7 upon 2, we are going to write next 3 terms. The next 3 terms will be basically very simple, right? 7 upon 2 plus 1 upon 2 will give you the next term because our common difference is 1 upon 2, right? So which is 8 upon 2 or 4. Alright, 8 upon 2 or 4. Then it will be 8 upon 2 plus 1 upon 2. That is 9 upon 2. Moving forward, we're going to find out the third term as well. That's going to be 9 upon 2 plus 1 upon 2. That is 10 upon 2 or 5 basically. So what is our sequence? Let's write it down. 2, 5, 5 upon 2, 3, 7 upon 2, we found out 4. Then 4, 9 upon 2, 5. So this is our sequence of AP whose common difference is 1 upon 2. Moving forward, we have minus 1.2, minus 3.2, minus 5.2, minus 7.2 and so on. Now, is this an AP? Well, to check that again, we're going to find out the common difference. A2 minus A1, which is equal to minus 3.2 minus of minus 1.2. This in turn will give you minus 3.2 plus 1.2, which is equal to minus 2.0 or 2. Then we're going to find out A3 minus A2. A3 minus A2 will give you minus 5.2 minus of minus 3.2, which is equal to minus 5.2 plus 3.2, which in turn will give you minus 2 again. Now let's see A4 minus A3. A4 minus A3. This implies minus 7.2 minus of minus 5.2, which will give you minus 7.2 plus 5.2, which is equal to minus 2. Now have a look at the differences. You find them common, isn't it? So D here is equal to minus 2. Now we know that the given list of numbers or the given sequence is an AP. Then we're going to find out the next 3 terms as well. We're going to just add minus 2 to the last number obtained, that is minus 7.2. So minus 7.2 plus of minus 2 will give you the next number, which is minus 7.2 minus 2, which is equal to minus 9.2. Similarly, minus 9.2 plus of minus 2 will give you the next number. Minus 9.2 minus 2, which will give you minus 11.2. Then minus 11.2 plus of minus 2 will give you the next number, which is minus 11.2 minus 2, which in turn will give you minus 13.2. Therefore, the next three numbers are minus 9.2, minus 11.2 and minus 13.2, whereas the common difference is minus 2. Moving ahead, we have minus 10, minus 6, minus 2, 2 and so on. So first let's check whether this is an AP or not. So minus 10, minus 6, minus 2 and 2. Now first let's find out A2 minus A1. That is, you're going to first find out the common difference and check, which is going to be minus 6 minus of minus 10, which is basically minus 6 plus 10, which is equal to 4. Then A3 minus A2 is minus 2 minus of minus 6, which is basically minus 2 plus 6, which is again giving you 4. Then A4 minus A3 is equal to 2 minus of minus 2, which is basically 2 plus 2, which is again giving you 4. So what is the common difference? The common difference is same, and the common difference is nothing but your 4. So D is equal to 4. Now this is an AP, right? The conclusion is that this is an AP because the common difference is same. Then we're going to find out the next three terms. Right? You're going to just add 4 to the last term. So it is 2 plus 4, which is 6. Then it's going to be 6 plus 4, which is 10. Then 10 plus 4, which is 14. So what are the next three terms? The next three terms are basically 6, 10 and 14. Moving ahead, we have 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2 and so on. So here, first one, A2 minus A1. We're going to first find out the common difference and check whether it's an AP or not. And if it's an AP, we're going to find out the next three terms, isn't it? Now, A3, first we're going to find out A2 minus A1. Then A3 minus A2 and so on. Right? So this is 3 plus root 2 minus 3, which is equal to root 2. The common difference turns out to be root 2. Then A3 minus A2, which is equal to 3 plus 2 root 2, right, minus 3 plus root 2, which in turn will give you 3 plus 2 root 2 minus 3 minus root 2, isn't it? Now here plus 3 and minus 3 get cancelled. You'll be left out with 2 root 2 minus root 2, which is root 2. Now what do you observe? The common difference is same, isn't it? The common difference is same. So this sequence is an AP sequence. Now we're going to find out the next three terms, isn't it? So you're going to just add root 2 to the last term. So our last term was 3 plus 3 root 2 over here. You're going to add root 2 to it. You get 3 plus 4 root 2. That will be your next term. Then 3 plus 4 root 2 plus root 2 will give you the next term, which is 3 plus 5 root 2. And then 3 plus 5 root 2 plus root 2 will give you 3 plus 6 root 2, which is your next term, isn't it? So the common difference is root 2, and the following terms are 3 plus 4 root 2, 3 plus 5 root 2 and 3 plus 6 root 2. Moving ahead, we have 0.2, 0.22, 0.222, 0.2222 and so on. Well, that's funny. Now let's find whether it's an AP or not. Right? A2 minus A1, which is 0.22 minus 0.2. Now what is this? 0.22 minus 0.2 is 0.02, isn't it? 0.22 minus 0.2 is 0.02. Then A3 minus A2 will give you what? 0.222 minus 0.22, which is going to give you 0.002. Oh, I see. Then A4 minus A3, that is 0.2222 minus 0.222, which will give you 0.0002. Well, look at the common differences. Are they same? They are not same. So this is not an AP. This particular list of numbers or a sequence of numbers are not in AP. Moving ahead, we have 0, minus 4, minus 8, minus 12 and so on. So here, first let's find out the common difference and check whether it's an AP or not. So A2 minus A1 will give you minus 4 minus 0, which is nothing but minus 4. Then A3 minus A2, which is minus 8 minus of minus 4, which is minus 8 plus 4, which is again minus 4. Then A4 minus A3 minus 12 minus of minus 8, which is minus 12 plus 8, and which is minus 4 again. Now have a look at the common differences. Are they same? They are same. So the given sequence is an AP and the common difference is minus 4. Now when we know the common difference, it's easy to find the next three terms, right? So you're going to just add minus 4 to the last term, which is minus 12. So minus 12 plus of minus 4 will give you the next term, which is minus 12 minus 4, which is minus 16. So the next term is minus 16. Then this is your next term, minus 16 plus of minus 4, which is minus 16 minus 4, which is minus 20. That is your next term. Then minus 20 plus of minus 4, which is minus 20 minus 4, which is going to give you minus 24. So what are the next three terms? The next three terms are minus 16, minus 20 and minus 24. Apart from that, the common difference is minus 4. Moving ahead to the 8th sub question we have is minus 1 by 2, minus 1 by 2, minus 1 by 2, minus 1 by 2. Now, many of you might be thinking that this is not an AP. Well, you are mistaken. This is an AP. Why? A2 minus A1. What is A2? Minus 1 upon 2. Minus of minus 1 upon 2, which is minus 1 upon 2 plus 1 upon 2, which is 0. Then, let's see the next one. A3 minus A2, which is minus 1 upon 2, minus of minus 1 upon 2 again, which is minus 1 upon 2 plus 1 upon 2, which is 0 again. The common difference is same, right? The common difference is 0. So, it is an AP. You must always remember that the common difference can be 0. Now, what will be the next three terms? The next three terms will be minus 1 by 2, minus 1 by 2 and minus 1 by 2, obviously, because the common difference is 0. So what was our last term? Our last term was minus 1 by 2. So minus 1 by 2 plus 0 will give you the next term, which is minus 1 by 2. Again the same procedure. Minus 1 by 2 plus 0 is equal to minus 1 by 2. Minus 1 by 2 plus 0 is equal to minus 1 by 2. So the next three terms are minus 1 by 2, minus 1 by 2 and minus 1 by 2. And the common difference is 0. Make sure that you always know that the common difference can be 0. Moving ahead, we have 9th sub question, which says 1, 3, 9, 27 and so on. Now A2 minus A1, the same procedure for all the sums. So 3 minus 1, which is 2. Then A3 minus A2. A3 minus A2, which is going to give you 9 minus 3, which is 6. Alright. Then A4 minus A3, 27 minus 9, which is 18. Have a look at the common difference. Are they same? They are not same. The difference, the common difference is not same. Hence, the given sequence is not an AP. Moving ahead, we have A, 2A, 3A, 4A and so on. Well, A2 minus A1 is 2A minus A, which is A. We are just finding out the common difference so that we can first know whether it's an AP or not. And then we can find the next three terms if it is. Right. Then A3 minus A2 is 3A minus 2A, which is again A. Then A4 minus A3 is 4A minus 3A, which is A again. Now have a look at the common differences. Are they same? The common difference is same. So D is equal to A. That means the common difference is equal to A. Now what will be the next three terms? The next three terms will be added, right? Added to 4A. First, the next term will be 4A plus A, which is 5A. Then 5A plus A, 6A. Then 6A plus A, 7A. 8A, 9A and so on, right? So the next three numbers are 5A, 6A and 7A and the common difference is A. Moving ahead, we have A square, A cube, A to the power 4 and so on. Now let's find out the common difference first. A2 minus A1, which is A square minus A. Now I'll take out A common. I'll be left out with A minus 1 in the brackets. Well, that brings us to the common difference. Then we have A3 minus A2. That's going to be A cube minus A square. I'll take out A square common. I'll be left out with A minus 1 in the brackets. Then A4 minus A3. A to the power of 4 minus A to the power of 3. I'll take out A to the power of 3 common. I'll be left out with A minus 1 in the brackets. Now have a look at the common difference. Are they same? Everyone, is the common difference same? No. Since the common difference is not same in all the cases, the given sequence is not an AP. Have a look at the sequence. Root 2, root 8, root 18, root 32 and so on. Well, now I'm in a confusion. Have to find out the common difference of this. Well, it's simple. A2 minus A1. That's what we do. Root 8 minus root 2. Now, many of them get stuck here. Root 8 here can be written as root of 4 into 2 minus root 2. Now, root of 4 is nothing but 2. Here we have root of 4, which is 2. So, it's 2 root 2 minus root 2, which is equal to root 2. So, in the first case, we got the common difference as root 2. Then moving ahead, we have A3 minus A2, which is equal to root 18 minus root 8. Now, this in turn can be written as, root 18 can be written as 9 into 2. Root of 9 into 2 minus root of 4 into 2. Now, what is this basically? This is 3 root 2 minus 2 root 2, which is equal to root 2 again. Then, A4 minus A3, which is equal to root of 32 minus root of 18, which in turn is nothing but root of 16 into 2 minus root of 9 into 2, which is nothing but 4 root 2 minus 3 root 2, which is equal to root 2 yet again. Now, have a look at the common difference. Is that same? Well, it is same, so the given sequence is AP. But wait, you're going to find out the next three terms. So, you're going to just add root 2 to the last number so that you can get the following terms, right? So, root 32 plus root 2. Now, root 32 can be written as what? Root 32 can be written as 4 root 2 plus root 2, which is equal to 5 root 2. So the next one is 5 root 2. Now 5 root 2, what is the value of 5 root 2? Basically, it is root of 50, isn't it? Root of 50 can be written as root of 25 into 2, and root of 25 is 5. So then we have 5 root 2. But this is going to be root 50. Then 5 root 2 plus root 2 will give you 6 root 2, which is nothing but root of 72. I hope this is clear, right? Which is basically root of 36 into 2, and root of 36 is nothing but 6. Then we have 6 root 2. But initially it's going to be root of 72. Then the next term is going to be 6 root 2 plus root 2, which is equal to 7 root 2. And 7 root 2 in this case is going to be root of 98. Alright, which is nothing but 49 into 2. Moving ahead, we have root 3, root 6, root 9, root 12, and so on. Now again, we're going to find out the common difference, a2 minus a1. Alright, a2 minus a1, which is going to be root 6 minus root 3. Now root 6 can be written as root 2 into root 3 minus root 3. Now upon this, I am able to clearly see that root 3 can be taken common. Right? So I'm going to take out root 3 common. I'll be left out with root 2 minus 1 in the bracket. As simple as that. Then a3 minus a2. Root 9 minus root 6. Now root 9 is nothing but root of 9, which is 3 basically, isn't it? Well, let me write it as root 3 into root 3 minus, now root 6 can be written as root 3 into 2. Root 3 into root 2. Now what I can take common out of this? Well, let me say that this is 3. Okay, 3 minus root 3 into root 2. Now I'll take out root 3 common. I'll be left out with root 3 minus root 2 in the brackets. Is that right? So I've just taken root 3 common, so that I'll be left out with root 3 minus root 2 in the brackets. Because here, basically here root 3 into root 3 is nothing but 3. Right? And I have taken root 3 common, and root 3 into root 3 is nothing but 3 minus again root 3 into root 2 will give you the same, right? Root 3 into root 2. That is your previous step. So that is the reason I have taken root 3 common, so that I can have root 3 minus root 2 in the brackets. Now this is my common difference, and this is my common difference in the first case. This is your first case and this is your second case. Now do you observe the common difference is same? No. Since the common difference is not same, the given series or the given set of numbers is not an AP. Now have a look at this. 1 square, 3 square, 5 square, 7 square, and so on. 1 square is 1. 3 square is 9. 5 square is 25. 7 square is 49. Now find out the common difference. A2 minus A1, which is equal to 9 minus 1, which is minus 9 minus 1 is 8, isn't it? Then A3 minus A2, which is equal to 25 minus 9, and 25 minus 9 will give you 16. Then A4 minus A3, which is equal to 49 minus 25, which is equal to 24, isn't it? Now have a look at the common differences. Are they same? Are the common differences same? No. Since the common differences are not same, the given set of series of numbers is not an AP. Moving ahead, we have 1 square, 5 square, 7 square, 73, and so on. Let's see whether this is an AP. 1 square is 1, 5 square is 25, 7 square is 49, and then we have 73. Now, A2 minus A1, which is equal to 25 minus 1, which is 24. Then A3 minus A2, which is 49 minus 25, which is equal to 24. Alright, then A4 minus A3, which is 73 minus 49, which is again 24. Now have a look at the common differences. Are they same? The common difference is 24 in all the cases. Since the common difference is same, the given set of numbers is an AP. Now when it is an AP, we're going to find out the next three terms as well, isn't it? So the next three terms are going to be 73 plus 24, which is equal to 97, isn't it? Then 97 plus 24, which is equal to 121. And then 121 plus 24 will give you 145. So the given series is AP. The common difference is 24. And the following numbers are 97, 121 and 145. And that dives us to the end of the video. And do not forget to subscribe to our channel Smiley Kids for more updates. Thank you so much.